Hi everyone, we're going to be learning about factoring polynomials by identifying the GCF. That's the first method we're going to be using today. Our essential question for today, does -1 and 1 count as the greatest common factor? Our first couple of terms and definitions we're going to be going over. Our first term is variable, and its definition is a letter that represents an unknown value that can change. So those can be, for example, those can be x, it can be y, it could be anything that represents a variable that just we can put any unknown in there. Our second term is factoring. This is when terms are multiplied together, they actually equal the original polynomial. So some examples of that, some examples of factors. So we learned this back in elementary school. When 21, the factors of 21, you see that when 1 times 21, that gets you back to your final answer. Or you could use 3 times 7, that also, when multiplied, gets you back to your actual answer of 21. In either case, when you multiply those two values together, they equal the original value. So what are the factors of 2x times x plus 5? Well, 2x is one of those factors, and x plus 5 is the other factor. When you were to actually multiply those, for now, it's just going to look like this when we actually multiply it. Our last term that you're going to be learning today is the greatest common factor. This is when the definition is the greatest variable and or number that divides into every single term of that given polynomial. And the abbreviation for it is a GCF. Now we're going to list out some steps on how to identify the GCF. So our first step is going to be number 1. So polynomial is simplified and written in standard form. Remember that standard form is where your exponents are going from the greatest value, highest exponent, all the way down to the lowest exponent. Our step 2 is both the number and variables must be common to all terms in order to be a GCF. If all terms do not have a common number or a variable, this means that there is no GCF. So it has to be in common with every single term or monomial that's actually in there. The number 1 is actually not considered a GCF. So if we had an example, so say like 5x squared plus 3x plus 2. So we can see that these numbers don't have anything in common, and they also don't all have a variable of x. So that means that the only thing they do have in common is just 1, but we're not going to take a 1 out of that. We'll just leave it actually blank. Okay, so then my third step, you're going to divide all the terms by the greatest common factor, leaving the remainder in the parentheses, and then this is actually called factored form. So I'll be kind of elaborate on these steps as we go through this. There's just one more little hint that I want to give you guys, a little side note. So this little side note right here, when in standard form, if the leading coefficient is a negative, then you actually are going to factor out a -1 out of that GCF. So as we're going through these examples, keep that in mind. So for our first example, we're going to do 18x squared minus 18x. So I like looking at just the numbers first and seeing what they have in common. Well, we know that they both have 18 in common, so we're going to write 18 as part of our GCF. Then now I'm going to go to my variables. They both have x's in them. When you're taking out variables though, you always want to take the lowest exponent. The reason being is that this term right here only has a 1x. This term here has 2 x's. So that means I am not able to take out 2 x's out of that term. So that we are only allowed to take out the lowest amount of them, which happens to be x. So on your assignment, you guys will be getting asked, like, what is the GCF of this polynomial? This would just be the GCF. If I have you put it in factored form or tell you to factor this, then you would be writing out the remainder. So the remainder goes in the parentheses. So that means that we're going to be dividing out that 18x for the first time. So 18x squared divided by 18x. That means 18 divided by 18 is just 1. Then we have x squared divided by x is 2 minus 1 exponent. So we just have our x. You don't have to write that 1 right there, so I'm going to rewrite this just so that you guys can see what it would actually look like. This is a parenthesis. And then now I'm going to divide, so -18 divided by 18 is a -1. And then x divided by x, we have no more x's, it's just 1. X divided by x is actually just 1, so 1 times 1 is still 1. So here we do have to put that 1 because it's actually stating that we had one value there. If we don't have that 1, then we would not be able to actually multiply this back to get our final answer. So remember, factors, when you multiply, you're trying to get back to the same answer. So let's go ahead and actually check our work here. So when we check our work, you are going to be multiplying and distributing just like we were in our previous video and multiplying polynomials. So now I'm going to do 18x times x, which is an 18x squared, and then we have an 18x minus 1, so times a negative 1, so that's a negative 18x. And we see that we got back to our final answers, so check we are actually correct on that one. Our next example, we're going to do 9x cubed minus 180x squared. So again, look at your numbers, see what they have in common. I know that 9 goes into 180 actually 20 times. If you guys didn't get that, you can use a calculator. So 9 is going to be the numerical value of my GCF, and then we're going to see that we have x to the third and x squared. Remember, you're always taking out the lowest value of the variables because I don't actually have 3 x's in that second term there. This is my GCF, 9x squared. Now I'm going to finish factoring it. I actually want to go through and factor this. So if I do 9x cubed divided by 9x squared, that means I actually just have an x left. And then negative 180 divided by 9 is actually negative 20. Make sure you're keeping your positives and negatives. And then that x squared divided by x squared is actually 1, but 1 times negative 20 is just negative 20. So this is our factored form. This portion right here is your actual GCF, but then this whole thing is actually your factored form. Okay, so that will be that's for our example on that one. Okay, our next and last example for factoring with the GCF for these ones, we're now going to look for, before we get a little bit more complicated problems, look again at your numbers, see how this one's a little bit different. This actually has a negative as our leading coefficient in standard form. So this is the case where I actually am going to take out that negative value. So we know that 4 goes into 8 as well, so negative 4 is my numerical value of my GCF. And I don't have any x's, so I don't get to take out any variables. So now I'm just going to divide out. So negative 4x squared divided by negative 4 is just x squared. And then we have our 8 divided by negative 4, which is going to be a negative 2. Again, that negative 4 is our GCF, and then the whole thing all together is our factored form. Okay, and then we have a few more examples. Now we're getting into trinomials, just getting a little bit harder. So we have 6x squared plus 2x squared plus 16. So for these values, we want to actually make sure we combine like terms first before we start simplifying. So we have our like terms here, 6x squared and our 2x squared, making sure that we are always in standard form before we begin to find our GCFs. So 6 plus 2 is 8x squared. Since we're just combining like terms, that exponent stays the same, and then we get plus 16. Now going from there, I want to see what my GCF is, and my greatest common factor is the numerical value of 8, which means I'm going to only have that value of 8. I have no variables in there, and then it's x squared plus 2. My next value, this one actually has a negative in front of that x, it already is in standard form, the highest exponent. It has a negative. We need to take out that negative again, so negative 3. And then these actually both have variables. We take out the lowest one of x, and now I have an x, and then, negative. 12 divided by negative 3 is actually a negative 4. So negative 3x times x minus 4. And our last example for the notes this time, this was a little bit more complicated problem. This is probably as hard as you're going to get to see these. This is actually representing that this is one term and this is our second term. These parentheses all mean multiplication. So what does this first term have in common with that second term? Well, we see that they both have x plus 2's in them. So that's actually the greatest common factor. So we have x plus 2 is our greatest common factor, and we're actually going to write in parentheses, we're going to do little brackets to help us do this. And now if I actually divide out these polynomials, so I'm going to do this on this side. If I have x plus 2 times x plus 1 divided by x plus 2. What would divide out and actually be 1? The x plus 2. So we are left over with just x plus 1 in that case. And then on this one, if I have x plus 2 divided by x plus 2, when those divide out, it actually equals a positive 1. So we're going to say plus 1. Close our brackets, and then that is actually our final equation, or our final factor. So x plus 2 happened to be our greatest common factor, and then we had our leftover, our remainders. In this case, in that first term, it was just the x plus 1, and in that last term, it happened to just be a 1. So this is our final answer for this case.